Hi everybody, good afternoon, good morning, good evening, wherever you are. Today we have here with us people from several regions of the world, and I'm very happy for that. My name is Aaron Muniz, I'm a mining engineer, specialized in drilling and blasting, and I graduated some 14 years ago. For most of this time, about 12 years, I've worked in one of the most important quarry groups in Brazil in the operations side. And then 2 years ago, I joined DataMine Africa, where I work here in our Johannesburg office as a drill and blast consultant. And I also lead our team for operations software, which includes DataBlast, for controller, Studio Survey, and DataMine. Today with me here is my colleague Fernando Zagatti. He's also a mining engineer that works here at Johannesburg on the operations team, and he's a truly DataBlast expert. All right, here we go then. Before talking about DataBlast, let me say a few words about DataMine. DataMine is the world's leading provider of technology for mining. We have solutions as software and consultancy for all the stages of the mining chain, since the exploration, geological data management, resource modeling, open pit and underground planning, operations, and also supply chain. Okay, in this range, DataBlast is sitting right here on the operations side as our solution for open pit drilling and blasting management. Right? Uh, the agenda for these presentations, will be having a series of 2 sessions. Okay, the first one is today, and we'll be talking about DataBlast itself. I'll give a general overview on the software. Then I'll be talking about a very typical drill and blast workflow and how DataBlast addresses this workflow. I will show you the software interface, its core modules, and then we'll be talking about the technology of true seam blasting and also about data reporting. Okay. Next week on the 11th, my colleague Fernando will be showing you a complete workflow in DataBlast. Okay, he will be opening the software and going through the whole workflow, designing a pattern, showing you the drilling, the measuring, the charging plans, and also the initiation as it goes in DataBlast. Okay. All right. So before we start talking about the software, I'd like to invite you to a quick thinking about drilling and blasting. The first question I wanted to ask you is, how important do you consider having good results in drilling and blasting? Well, we know that drilling and blasting is one of the first activities to be performed on an open pit mining operation, right? So if we don't perform a good drilling and blasting, we may compromise and increase costs for all the downstream activities. I'm saying that because poor drilling and blasting projects and its execution can lead to poor fragmentation or irregular surfaces, among a number of other undesired results. These examples of bad results can compromise the productivity, for example, of the load and haul fleet, and also the primary crusher. Okay. Bad blasts, poor blasts, they can also compromise the stability of the mine, which can be a serious hazard for its operation, and also even reduce the mine's available reserves and its total value. This is a risk because an unstable pit may require changes in the overall slope angle, or even need to have some areas blocked. Okay, so loss of reserves. Okay. And of course, other undesired results can be related to the environment, like high vibrations or high air pressure levels. That said, I'd like to think, why not put some more attention to your drilling and blasting? The technology allied with procedures and with best practices can make all the difference for our operations. Okay. Well, so I'd like to invite you once again to think a little bit further about some questions like, uh, do you think you are spending too much time doing design work at the office? I mean, for drill patterns, for charging and timing plans, whatever. Are you using a dedicated and proper tool that helps you to do that? And also, uh, are you being able to know and acknowledge what is really happening in the field? For drilling, for charging, what I'm asking is, do you really know if the pattern geometry or if the depths or explosives chargers that you designed are really being followed by the crew in the field? And even further, where are you storing the drilling and blasting real data, the actuals? I mean, the information that comes from the field, and it, in certain cases, even comes from your contractors. Do you have control over this information, right? Uh, Even more, are you being able to easily and quickly use these results to understand what you did wrong, what you did right, and something that may need to be corrected next time, right? This is the way to optimize. Are you being able to use this information to optimize uh, your blasts? Okay, it's interesting to think about all of these, right? Well, what I'm going to show you next is a tool to address all of these, DataBlast. Just wanted you to keep these questions in mind as we go, okay? So what is DataBlast then? DataBlast is a complete solution to perform and manage the entire drill and blast process for open pits in one single application. I think that would be the best definition for the software, although a little simplistic. Okay, of course, the software does much more than that. This is a very wide field. Some of the features of the software, DataBlast is a multi-user system to which several different people with several different roles can have access, and these profiles are fully customizable. You may have different people authorized to do different things over the same data set. It's a very intuitive software, although very powerful. DataBlast is also easy to use, right? A trained user can design very complex and big patterns in a few minutes, 20 minutes, and everything complete with charging plans, with timing plans. So the tools that DataBlast brings are very straightforward. It is also a very modern platform because it integrates seamlessly the field with the office. Okay, it brings technology to your operations. DataBlast integrates itself with most of the geonavigation systems we have currently, and also has its own field platform, which is BlastPad. Okay, even if you don't use a geonavigation system, if you want to exchange data electronically with the field, we have BlastPad, which is part of the DataBlast system. Also, and very important to say so, DataBlast works over a centralized database. All the data is stored in one single database, and all the users have access, a controlled access to the same data. Okay, this brings to the operation of what we call the data integrity. Okay, the database is stored in one server and is hosted by Microsoft SQL Server. Okay, so now we are talking about backups, uh, controlled access to the data, and all that you need to ensure that your data is properly stored and retrievable. Okay, and also it's a very powerful system. Over 130 parameters can be stored, handled, retrieved per hole. Okay, so it's a very wide system. Okay, let's Let's show here and talk about a very typical drill and blast workflow. What are the main steps? And I'll say a little bit how DataBlast works with each one of these steps. Okay, so the very first moment is the design. Okay, we upload some data to the system like topography, mining blocks that usually come from the mine planning team. Okay, eventually even dig lines that can come from your grade control system. All right, and uh, we use this data to design our blasts. Right, DataBlast is very friendly with file formats, so it can import drawing files, CSV files, and DataMine files, of course, and even some competitor software files. Uh, and it brings a lot of tools. We'll be showing some of them to easily design your blasts. Okay, so it will calculate for us several parameters like bearings, collar coordinates, right? Based on and depths, based on some inputs that we enter in the software for the pattern creation, right? Okay. See, once we designed the blast, it's time to send it to the field. And there are several ways to send the drilling instructions to the field in DataBlast. Since the most automated ones, which would be drill navigation systems, uh, even through BlastPad, its field platform, and also we always have the option to send it manually, to print reports with all the information that's necessary and send the drilling instructions to the field manually in a printed report. Okay, and then the pattern is drilled. Uh, it's very important to track the actuals, what really happened in the field, how our pattern was really drilled. Uh, we can see and we can imagine that some things like coordinates, for example, the positioning of the holes, they will never be exactly the same as the designed, right? Why am I saying that? Is it because my drilling crew is not very good or because I have problems with my drill rig? Not always, right? It can be a problem with accuracy, but it also can be due to adjustments that are necessary in the field, right? Sometimes it's not possible to drill exactly on that XYZ designed position, right? Some other parameters that do change uh, during the drilling can be the depth, the angle, bearings. We have diversions. It's normal while drilling. So it's very important to be able to track the actuals because we are not going to charge and blast this one, the designed. We are actually going to charge and blast the drilled, right? So it's important to understand what happened, make the corrections for the downstream process, and uh, store properly this information. Okay. Uh, before the charging and after the drilling, we still have another step. Okay, in between, we have also in certain cases, and DataBlast handles that, the QA/QC, right, or the measure, the quality assurance, quality control, which is controlling the quality of our blasts by measuring them a few days prior to the charging. Why am I saying that? If we are finishing drilling today and we are gonna charge our blast tomorrow or the day after, uh, okay, it's fine. We may have the same conditions preserved, but sometimes for scheduling reasons, for planning reasons, we are finishing the drilling today and we are going to charge and blast in 1 week, 2 weeks, even more. Okay? So a lot of things can happen in between. A lot of things can happen after the drilling. Like for example, we may have had rain, and this rain may have dragged mud to the holes, and then the depth is not preserved. The depth needs to be corrected, right? or we may have collapsed holes during this period due to vibrations in other from other blasts. Okay, so it's very important that a few days before the charging, someone goes there and measures what really happened, right? And we have in DataBlast tools to help with this process as well, as we are going to see. All right, once we are happy with our pattern, once all the corrections were done, it's time to make the charging. And DataBlast as a drilling and blasting management system, of course, brings a lot of tools to easily charge and so that the holes easily make the charging plans with several different kinds of explosives, several different kinds of stemming inert products like gas bags, plugs, okay? Different kinds of primers, electronic detonators, non-electric detonators. It's a full suite of products that can be included in the software for the charging plans. Okay, and also after charged, we have the timing. In DataBlast, we also have a lot of useful tools and very straightforward tools to make timing plans. And not just one scenario, we can make, for example, several different timing scenarios and run analysis tools to show us which one is supposed to give us the best result. Okay, non-electric, electronic. In the case of electronic, we are gonna see that next week. We have even tools for automatically time the blasts according to some parameters we enter, which is very helpful for big blasts, of course, and also when we need to do selective mining. So these tools for auto timing, they will help us to set directions of movement and everything. Okay, before we move to the software, uh, two more things to say. First, right, this is a very straightforward process, but DataBlast doesn't require us to do step by step in this order. What we can do, for example, is to design our blasts, skip the drilling, do preliminary charging plans and timing plans, run an analysis, check different scenarios, different possibilities, eventually based on non-desired results, uh, go back to the design, adjust the design plans, the parameters. Once again, run the charge, the timing. It's quick, very quick to do that, very quick to draw different scenarios, run the results until we find a good option, right? And then we send for the drilling. When the drilled and eventually even the measured information return from the field, DataBlast will automatically recalculate for us the chargings. Okay, so we are not wasting time. We are earning time by doing that before. And other very important thing to say is that BlastPad, the field platform for DataBlast, also acts in several of these steps, as for example, drilling. So we can, as I said, we can send information to the field via BlastPad, but we can also receive this information back from the field, the actuals. BlastPad is capable of capturing with operators entries. BlastPad is capable to capture the drilled information and send it back to the office. The same happens for measuring. It's possible to send as an electronic clipboard, send the holes to be measured to, or even backfilled to BlastPad and capture back the actuals. And this happens as well for charging. BlastPad brings to the field very detailed instructions on how to charge each one of the holes for the blasting crew and captures by the operator's entries, it captures the actuals from the field as well. Okay, so now let's move to the software. Let me open DataBlast here and show you how it looks like. So here is the software. Here is DataBlast. This is the main interface for the software. On the center, we have our drawing area, the area where we are going to perform activities. In the top, some ribbons bringing some specific tools for each one of the activities that are being performed. These tools, most of them change according to what we are doing. It's important to say that DataBlast is built over a CAD platform, so it works over a CAD engine, and then it brings a very complete set of CAD tools for drawing and entities, and also for manipulating entities like strings, points, polylines, surfaces. Okay, DataBlast works with surfaces; it doesn't need solids, and it can also generate its own surfaces. It's a very powerful uh, tool here. We also have some export and reporting patterns, general ways. This block model, it's a brand new function from the latest release of DataBlast. So through this function, it's possible to import MWD data from your navigation systems, and with some specific bunch of data, we can build block models over our benches, right? MWD stands for measure while drilling. Here on the left, we have the items tree. This works pretty much as a Windows Explorer, and then you can expand your data here. This brings all the data that's in the database, and as I said, DataBlast can handle a lot of data. All this data is stored in the database, in the SQL Server database. And for example, we can have different units of the same company storing data in the same place. In one single unit, we can have different pits. In my case here, I have pit north and south. And here we can store all the data related to drilling and blasting for the entire pit. So topographies, surfaces. Let me turn on here some of the data that I have. Let's say, for example, topography for one specific month. Okay, so here I have my strings. I have my surface here for this topography. Let me switch on the render mode and turn it a little bit slowly because of the streaming, so that you can see what's happening. So here we can have a view on 3D of our pit, right? And I can store here as well, for example, some periodic mining blocks. In this case, let me turn on, just as an example, I have 4 mining blocks here that are going to be blasted in that specific period, in this case, April. And also, of course, all the blasts for this pit. We can even create subfolders here. This is a matter of organization, and also the names, they can follow your convention names, your site's convention names, without major problems. And then here we have, as in my dataset, in my example dataset, I have a few blasts here. Let me open one for us to see. So I have one blast designed for this block. It's actually already designed and blasted. And here we can see the holes, all right? The holes and the whole track, because it's an angled hole. So here I can store not just design information, but also the actuals. We are going to see later that the drilling information is already here, the measure information is already here, even the backfilling information is here. All the information related to my blast pattern is also here, the charging, the several alternatives of initiation of timing I may have done. In this case, I have 3 to compare and to choose the best one. So they are stored here. And we can also store, for our fragmentation prediction model, we can also store different alternatives of charging, let's say, different kinds of explosives used, and run different simulations of fragmentations. I'm gonna show later. Uh, and even more, as this is a database, well, so far all the files that I have shown, except for the topography that I have imported, right? So I imported topography, I imported the mining blocks that came from my mine planning team, but all the other entities here, like the blast pattern, the charging plans, timing plans, they were created by DataBlast. So more than files created by DataBlast, I can also store in the database all different formats of external files, like an example, an external report in PDF that was created by someone else, and it's relevant to be stored here. An example, I can store pictures like before the blast, after the blast. I can store video recordings of the blast. So all the information is stored in the same place because everything is done with one single platform. And this makes it very easy when we need to retrieve some blast data for any reason, maybe to for an optimization in the future, maybe to understand what was done at a certain point. So everything is here, everything is easy to retrieve, everything it's in a very straightforward way, and it's very easy to have this information whenever necessary, right? Let me show some tools for in the design where we designed up the blasts. So I'm showing you, let me switch off some stuff here so that we can see it clear. Block, for example, yeah, let's leave the strings. So here I have one big blast, which is the blast 03. With the designed holes, in this case you are seeing different colors because it's a color, code convention. It's a color code convention because this is a performed blast as well. It's not just designed. This was already drilled, measured, charged, and blasted. And then we can see here some major tools for the blast design, some surfaces assignments which are important for the software. Once again, CAD tools to eventually draw and manipulate whatever is necessary. Under these ribbon holes, well, here is where the magic happens. Here is where we have the tools for creating the patterns. So I'm not gonna use any one of these tools. We are going to address this in the section next week, and you'll be seeing how a pattern is properly designed. But just to show you, just to say some words about the tools, we have tools for creating grids, holes over lines, individual holes, even giving instructions to automatically redesign holes that may have collapsed, right? Tools to manipulate existing holes, whatever is necessary for designing and adjusting a pattern. Under hole numbering, we have an easy, quick, very straightforward tool to set the IDs or to number the holes. So we can put the name we need. We can use the convention which is adopted to our mine without any kind of restrictions, right? Very easy and flexible way to number holes, and also very quick. And over the burden check, well, this is a very important tool. The burden checker is a tool to create cross sections of the desired holes, most of the times the face holes. And these cross sections, we can define the maximum and minimum distances or maximum and minimum burdens for the holes. And we can see if the face holes are within these limits. It's very important to check that when you are designing a pattern, because a hole that is too close to the face can generate flying rocks, right? If we don't do a charge relief or something like this. And a hole, on the other hand, a hole that was too far from the face, it's also undesired, because it can compromise the energy distribution in the rock mass, and it can compromise fragmentation and also even generate higher vibrations. So it's very important to check if our holes, especially the ones close to the face, if they are within the limits. This is a tool that brings this functionality for us, right? I'm not going to make any changes here. So as I said, this is our main designing window. Here in this ribbon, I have some viewing tools like zoom, orbit, viewport to help us with the viewing. On the right, the snap bar, so to help us with the drawing, we have snap functions. Here on the bottom, some tools to switch on and off some entities, like for example, the numbering. If I don't want to display the numbering for any reason, I can click here and switch it off, or switch it on. The holo tracks, right? I can display just the colors if I want, and a lot of other stuff. This also changes, this also varies according to what we are doing. Here on the right, very important, we have our properties pane. Here is where we can see a lot of different information, not just for holes, but for any selected entity. If I select a string, it will bring me properties for the string. If I select one hole, it will bring me a full set of properties and information of that specific selected hole, in this case the C9. So I can expand here, I have general information about the design. Here an example, information about the drilling that may be different from the design. Usually will be measuring, charging, everything is here to be seen very quickly, right? It's important to say that all of these windows, they are dockable. So if you use multiple screens, which is not my case here because of the webinar, to better to present in one screen, but we can also undock these windows and place them on a different screen and make our drawing area bigger. Okay, let me dock it again. All right. So this is the design module. Here we have on this lower ribbons, we have our activities. So this is the process, the workflow that we have already discussed, since the design to the initiation, those steps. And we also have two extra activities here, which are fragmentation and inventory. I'm going to talk about them as we go. So we made the design. Let's go for the drilling now. Now we can see that a few things have changed, and I'm going to explain about that. So here we have different tools, as I said, according to the activity we are performing. We have specific tools, specialized tools, and the drill module is the part of the software that handles all the exchange of information with the field when it comes to drilling, right? This case, for this blast tree, I have as drilled information. So what we are seeing here in blue is the real hole, is a real hole, real drilled hole. Okay, I can switch on, for us to see here, I can switch on here in the bottom the designed information. So let's pick one of the holes here, the F8, for example. So in white, I have the designed information, so how the hole was designed by the engineering, and in blue, the as-built information. So here we can see we have some diversions on bearing, probably angle and depth, and also positioning, right? So the drill module will show us the differences and how accurate we were on, while drilling. Okay, up here we have some reports. So these are quality assurance reports. We can measure the accuracy of our drilling processes, not just related to depth, but also to positioning. So let me quickly show you one example here. So here is my depth check. I can check how accurate my drilling was in terms of depth. I can vary the tolerance. Let's put half a meter, and here let's even rotate this in 3D, and here I can have a visual display on the quality of my drilling related to depth, right? Each one of the colors mean a different thing. The blue ones are the ones deeper than the tolerance, the red ones are shorter than the tolerance, and the green ones are the holes in specification. We can also see it in 2D, although I like it very much in 3D. We can measure accuracy of the positioning for the color, for the toe. Let me open one other example here of report. This is a report that can be printed. And important to say, this is just one example. This can be customized for your mine standards. You can create, if you don't have a standard, we can create one. And you can change, we can change here the kind of information that's displayed, the headers. We can change what's necessary, the graphs, right? So this one is bringing me an evaluation of the depth, and I also have here something for the accuracy, a target graph for accuracies, right? Just as an example. Going further, measure. So the measure is in that workflow we shown is the QA/QC. Okay, so when the measure, we can send to the field, to an auxiliary in the field, all the drilled information, and the person can go there and check if the hole is still there, if it hasn't collapsed after the drilling, if the depth is okay, right? And another important function for the measure is not just the QA/QC, but also the backfilling. If a hole is deeper than the tolerance, well, it's important to correct this depth. It's deeper than necessary. It's important to avoid the irregularities in the toe. It's important to backfill, to put material in this hole. And so this module, the measure, also generates for us backfilling instructions. I even have one as an example here. Let me switch on. Right, and here I have a set of holes that were automatically understood by the software, identified by the software, and I have a set of holes that had to be backfilled. I can send it electronically to the field via BlastPad, as I said, or I can even print these backfilling instructions and send it to the field. If it is electronically, I can also receive this information back from the field via BlastPad. Okay. In the charge module, here is the place where we are going to do our charging plans. Let me switch on. So I have a very big pattern that was charged by the software. We give preliminary instructions to the software on which kinds of explosives to use according to the hole condition. If the hole is dry, if the hole has water. So we give the software some preliminary instructions that will be stored in the database. We give instructions to the software on how to charge, like an example, production holes, pre-split holes. Of course, these holes, they have different kinds of charges. and the software, when the software finds that specific condition, it will place that charge automatically. And of course, it will automatically calculate for us the total of explosives and even the explosives per hole and some other numbers. I wanted to show another blast here that I also have in this set. Let me switch on the topography again. I have one blast here which is removing this ramp. This ramp was a ramp created in rock, was built in rock, and I have a blast that is removing this ramp. So let's have a quick look on this blast. So here, let me even rotate this so that we can see it better. So here, as an example of what I'm saying, I have variable depth, of course. This is the higher part of the ramp, so the holes are deeper, and these are shorter holes. And according to the depth, I have created a rule here in DataBlast, quick and easy. I have created a rule that according to the depth, the shorter holes, they will be charged with a different kind of explosive, which is shown by a different color here. Also, to make it graphic, I have also chosen to use 2 primers in the deeper holes and just 1 primer in the shorter holes, right? In this example, I also have a pre-split line which is running here on the back, on the face, to help to remove this ramp properly. So also a different kind of charging, which is already here, everything calculated in one single blast. Just as an example on how DataBlast is flexible and powerful also when it comes to charging. Initiation, let me switch this off. Let's see the top view again, and let's go back to that big and beautiful blast, the 03, which is already blasted. Right, moving to the initiation. So here is where I have my tools for the timing, for setting the time, the delays between holes. So I have here for this blast, as an example, 3 different options, and although it's a big blast, it's very easy to do different options. It's very quick. The tools make it very quick. So when I activate one, let me bring this window here. So when I activate one, I have some tools to make the timing, different kinds of surface detonators, and I can also have a different scenario, for example, where the initiation point is here, different timings being used, and very quick and easy to analyze everything. Here over the analysis, we have some tools to check each one of these scenarios we have performed, like firing simulation, timing contours, a burden relief map. We also have an analysis of decks per delay in case we have multiple decks, maximum instantaneous charge and charge by time window, and even a very useful, a very important vibration prediction. It's a numeric model that helps us to predict vibration. This is an example for non-electric. We also have the option to use electronics with different timing options, with different timing tools like box, egg, contour lines. These tools will help us to time a blast very easily and quickly. For the fragmentation, in this case, let's open here. This is a schist. I have a rock type here, rock model here. So I can enter several different geological information for my rock to help me to create the fragmentation prediction model. And I can assess different scenarios on charging. In this case, for example, so this would be a charge with emotion. let me switch on a second analysis here. This would be a charge with info, so I can create different scenarios for charging, for pattern geometry, and based on the SwabRec model, a very powerful fragmentation prediction model, I can have an idea on the fragmentation which is expected for my blast. I can also print a report if necessary. This is also customizable, and this report will give me some specific information on the rock and the expected result. Once again, we can change these and customize as necessary. And to finish here quickly with the software, the inventory, this is a very useful tool. With it, we can control our inventory movement, right? So we have here all the kinds of explosives that are registered in our database, and we can record movement for each one of these explosives, this material, which is very useful when we need to control explosives movement in our magazines. Okay, so I'm almost running out of time here, but let's go back to the presentation, and I still want to show you some other interesting features on the software. A very powerful DataBlast function is its capability to work with the true scene blasting through the module GBlast. So this module is built for a specific application where we have stratigraphic deposits like coal or phosphate, for example, and in which one single hole intercepts several different kinds of materials, like uh, as this image shows us, it can intercept waste, the ore strata, and then waste again, sometimes even more stratas. So these holes, they have to be charged in a very specific way. We may need for each one of these materials, we may need a different kind of explosive, or even not using explosives, as in coal, for example, a very soft material. DataBlast will help us to understand all these interception points, and will help us to do very complex charge standards with very complex charging instructions for each one of the holes. And this will vary even in the same blast pattern, because each one of the holes is in a different position. The GBlast helps us not just with charging, but also with timing, because in a hole like this that has multiple explosive stacks, we may need as well multiple different primers blasting at different timing. So it's also possible to do Z timing zones here and create different timing sequences for each one of the decks. One very important thing about GBlast as well is that through the system MWD, once again, measure while drilling, we can input information that comes from the field, from the drilling rigs, and according to this information, the stratas, if they are different than the estimated by the geology crew, they can be automatically updated with the system, and also the charging standards, the charging instructions will be updated as well. Let's talk now about data reporting. DataBlast also has a module entirely dedicated to compiling and reporting all the information sitting on the database for all the existing historical data. If you have 10 years of historical data in your database, you can export this information and generate reports about all of it. All project characteristics or the actuals that came from the field will be made available for the generation of customized reports, and also for the process management. All this data can be exported to a third-party software as the Microsoft Power BI or Excel, and there we can create fully customized reports to fit the company's needs. Once the this database is modified automatically and everything is connected, any new data received will also update these reports. So this can be useful not just to understand what happened in the past or what's happening, but also as even as dashboards. We can create dashboards that are updated as the data comes. Let me show one example, some quick examples here. This is Power BI, right? And this was populated with some information. So it's important to be clear. Those are just some examples. Well, Power BI, with Power BI, the sky's the limit. We can create several different kinds of graphs, charts, and bring and display the information in different ways, dependencies, and everything. So let me just show you some very quick examples on what can be done. Here would be a comparison year by year. We can even put here month by month of the forecasted, drilled, and the actually drilled. Right? We can even see this by machine, by operator, by shift. If the information is there, it can be reported. A second example here, as I said, by shifts. Okay, so for one specific month, by date, we have here total meters drilled by shift, day and night. This would be kind of a dashboard. So we have several different patterns here. And here we have the status of each one of the patterns. So in this case, let's say the 936 is just designed, the drilling didn't start yet, while the 934 is 93% drilled and on, right? And this changes as the information comes. So once the system is all connected, this is updated as soon as the new information is available, a live dashboard. This is one example I really like. This would be one management for one specific pattern, in this case 934. So here we have some general information about the pattern, how many meters were designed, how many meters were already actually drilled, right? Even we have here an accuracy graph, a target graph for accuracy, for colors, for tolls. So we can even see here, we can even already have an idea on the accuracy on our pattern. Here we have these variances, right? This positioning variances and depth variances by machine. So in this case, I have 3 machines drilling the same blast, each one with its set of holes. And we can even filter by machine. So if I click here on the DR009, I can have an idea on the accuracy in this machine. If I see here, for example, these points too far from the center, I can even assume that this machine can be with some kind of issue, some kind of technical problem. Here is by machine, but we can even filter eventually by operator, by shift, whatever we want, right? So this is the power that's brought us by the reporting module. And that's what I had on the agenda for this session today. As I said, this webinar is being recorded and the recording will be made available for you as soon as it finishes. Just as a reminder, once again, next week we will be in a second session, we will be showing you the software working itself, right? A pattern, a whole life of a pattern since its design, drilling information, measuring, charging plans, and the initiation. So just as a reminder, if you didn't register yet, the registrations are open. Please make sure you join us so that you can see how it is complete and how the software really works, right? Let me see. Unfortunately, I'm out of time, but we will be addressing, we have some questions here. We will be addressing these questions by email later. I just wanted to say thank you very much. Our contacts are there. Here you have my email, Fernando's and Inzaka's. Inzaka is our third member of the operations team. Please feel absolutely free to contact us at any time with questions, with doubts, with other things that may come about drilling and blasting. And even if you just want to discuss drilling and blasting, if you want to share knowledge, if you want to exchange some knowledge, please feel absolutely free to contact us. We love to do that. We love to discuss drilling and blasting. And okay, once again, thank you very much. Thank you for being with us.